We've been drawing analogies between, I guess we could say, traditional multiplication or scalar multiplication. And the first one we drew is when you have traditional multiplication, you multiply 1 times any number, and you get that number again. And you could view 1 as essentially the identity number, or this is the identity property of multiplication. You multiply 1 times any number, you get that number again. And that essentially inspired our thinking behind having identity matrices. That, hey, maybe there are some matrices that if I multiply it times some other matrix, I am going to get that matrix again. And you've probably shown for yourselves that you can do it in either way. You could have some matrix times an identity matrix and get that matrix again. Now, if matrix A right over here is a square matrix, then in either situation, this identity matrix is going to be the same identity matrix. But if matrix A is not a square matrix, then these are going to be two different identity matrices depending on the appropriate dimensions. Now, let's see if we can extend this analogy between traditional multiplication and matrix multiplication. We know that there's another special number in traditional multiplication, and that's a 0. So we know that 0 times anything is equal to 0, or anything times 0 is equal to 0. So what would be the analogy if we're thinking about matrix multiplication? Well, it would be some matrix that if I were to multiply it times another matrix, I get, I guess you could say, that same 0 matrix again. And that is what we call it. We call it a 0 matrix. So if I take some matrix A, and essentially if I multiply it times one of these 0 matrices, or if I multiply one of these 0 matrices times A, I should get another 0 matrix. And it depends on the dimensions. You might not get a 0 matrix with the same dimensions. It depends what the dimensions of A are going to be, but you could imagine what a 0 matrix might look like. For example, if A is 1, 2, 3, 4, what's a 0 matrix that I can multiply this by to get another 0 matrix? Well, it might be pretty straightforward. If you just had a ton of zeros here, when you multiply this out, you're going to get this. You take the dot product of this row and this column, 0 times 1 plus 0 times 3 is going to be 0. You keep going, 0, 0, 0, 0. If we had a, and just to make the point clear, let's say we had a matrix 1, 2, 3, 4, 5, 6, 5, 6. So over here, we want to multiply this times, let's see, in order for the matrix multiplication to work, my 0 matrix has got to have the same number of columns as this one has rows. So it's got to have 2 columns, but I could make it have 3 rows. So it could look like this, 0, 0, 0, 0, 0. And I encourage you to multiply these two. Pause the video right now and see what you get. Well, when you multiply them, let's think about it. So the top left entry, so this is, let me just write the dimensions. This is a 3 by 2 matrix. This is a 2 by 3 matrix. So we know that we have valid matrix multiplication going on right over here. Same number, the number of columns in the first matrix is equal to the number of rows in the second one. And we also know that the resulting product is going to be a 3 by 3 matrix. So it's going to be a 3 by 3 matrix. And I'll leave it up to you to verify that all the entries here are going to be, all of the entries here are going to be 0. And it makes sense. You could go through the math, but you could see, well, you just, every time you're multiplying, say, this row by this column to get that entry, well, you just have 0 times 1 plus 0 times 4 to get that 0 there. But the whole point of showing you this example is we have one 0 matrix multiplying by this, being multiplied by this matrix right over here, and then we get another 0 matrix, but it has different dimensions.